Have a go at calculating 92 times 17 plus 34 times 4. When you've got an answer, what do you notice and why does this work? Can you write your own example? Okay, so I'll typically use this task as a sort of start a do now activity. It'll be on the board as pupils come in through the classroom and they'll get out their books or the whiteboards and they'll have a go at it. And virtually every time I've used it, pupils have gone to the grid method or column method and worked out these two products individually and added them together. And most of the students get to a nice round answer of 1,700. And if you don't, you can quickly identify those students that might need a little bit of extra help. But then the real question comes in, why is it such a nice round number? What's special about 1,700 and the numbers in this question? And you might need to do a bit of prompting here. Look at the 17, for example, the 92 times 17. What's special about 17 and 1,700? And hopefully they can say that, well, it's the same as 17 times 100. So where are we getting these 117s from in this question? Well, we've got 92 of them straight away. 92 times 17 is written there in the first part of the calculation. So where does the other 8 17s come from? And again, I find that quite often you need to nudge them here into saying, okay, what's the relationship between 34 and 17? And at this point, things start to click. Oh, sir, I reckon 34 is 2 lots of 17. Okay, so can we break down 34 and just write it as 17 times by 2? And then multiply it by the 4 in the end. So we're introducing, which is the main point in this task, we're introducing this idea of breaking down numbers, which is going to lead towards prime factorisation and the fundamental theorem of arithmetic. Now we've broken it down into 17 times 2 times 4, we've got this idea of commutativity going on. We can do multiplications in any order that we want. So let's choose to do the 2 times 4 first. So we can rewrite the whole calculation now as 92 times 17 plus 17 times by 8. And here you can see where you've got your 117s coming from now. You've got 92 times 17 plus 8 lots of 17. So together you've got 17 lots of 92 plus 8, or 100 lots of 17. Okay, so where can you go with this now then? Well, I quite find it useful to get pupils to generate their own examples here, but you'll probably find they need a bit of scaffolding for that. So I refer to the first one where we've got this nice round answer of 1,700. And I say, okay, let's start with the answer. And what if the answer here was a nice round 1,600? Can we sort of backwards reverse engineer this and come up with a calculation which will give us a nice round answer of 1,600? So the first thing we need to notice is that it's 16 times by 100. So let's partition this up into two different groups of 16. Now, in the first instance, you might want to tell them that you probably want to have even partitions, but then you can have a discussion why even ones don't work. So let's call it 16 times by, 82. And then what's the number bond to 100 for that? Well, it's going to be 18, so 16 times by 18. So that's still got this nice round answer of 1,600, but at the moment it's too obvious because we can see how we get our 116 straight away. So how can we alter this one? And maybe even how could we alter this one as well? So let's look at this first one. If we double the 16, if we times the 16 by 2, I'd have to halve the 82. So let's double the 16 and get 32. So I've basically done 16 times 2. So that means I need to remove a factor from this 82 here. So that becomes 41. Now I've done that just in one step quite quickly here, but you might need to write this out in full for students to make sure they fully appreciate what's going on here. Don't assume that you can just jump from this step to this step without a bit of explanation. On this second one, let's do it the reverse way maybe. Let's let's halve the 16 this time. And get 8. Now because I've halved the 16, taken a factor of 2 out, that 2 needs to stay somewhere. So I'll put the factor of 2 into the 18, so that will now become 36. Now all of a sudden, this calculation looks very different to the one above it, but crucially we still know it has an answer of 1,600. So you might want to get students to generate their own examples, maybe swap with their partners and see if they can come to their nice round solutions. And I mentioned at the start of this, partition into even numbers, into two even numbers which number bond to 100. If you choose odd numbers, then you end up getting some difficulties when you start halving. But there's nothing that says you have to just divide by 2 and times by 2. You could take out factors of 3 if you want, factors of 5. You can have all sorts of fun with this problem. This is just the basic example, if you like. But you'll find that pupils will often run with this and start taking out factors of 3, 5, and so on. Maybe starting off with larger numbers than 1,600 as well. So, as always, any thoughts in the comments below.